Virtual reality, or VR, shows considerable promise as a pedagogical tool, but requires further testing to better understand its efficacy in educational settings. Further research is needed to determine whether the promising results obtained in educational contexts are due to the technology itself or a byproduct of its interactive nature. The cognitive affective model of immersive learning posits that, due to its interactive and immersive nature, VR technology can enrich learning by producing higher levels of presence and agency than traditional methods of teaching. Presence refers to feeling as if you are there in the virtual world, and agency refers to feeling a sense of control within it. Previous research has produced conflicting results, where those in support of VR as an effective learning method lack an interactive component in each condition, indicating that the VR groups may have performed better because of the interactive nature of the teaching. Stereo vision, one of the ways in which we see depth, provides information about the 3D structure of the world due to binocular disparity between the two eyes. Stereo vision can be demonstrated well using head-mounted displays, making this application area particularly suitable for VR. Thus, we aim to investigate the efficacy of using VR as an educational tool compared to traditional teaching methods, using the example of stereo vision, and to examine how the addition of an interactive component across all learning groups addresses a key limitation of previous studies. To achieve this, 60 participants were split into 3 groups: lecture learning, VR learning, and video learning, to learn about stereo vision. Results showed that significant learning occurred across all 3 groups, but that one group was not superior to the others in terms of knowledge acquisition. Groups did not differ significantly in previous experience with computers, games, or VR. Self-reported engagement level did not differ between groups, and cybersickness was not found to impact participants. These results show that VR technology can be used as an alternative for lecture-style or video-based activities in the context of teaching stereo vision in a workshop-based design. Furthermore, these results indicate that an interactive component in an educational setting is important for both knowledge acquisition and participant engagement. To conclude, this research has contributed to the literature surrounding the efficacy of VR as a pedagogical tool and is, to the best of our knowledge, the first study to use VR technology to teach stereo vision. Thank you for listening. We will be presenting our poster on the 28th and 29th of June in Athens, Greece.